I am Mr. Pankaj Jindam, Assistant Professor at Department of Humanities and Science, Walchand Institute of Technology, Solapur. In this lecture, we will see electrochemistry and its applications. A learning outcome for this topic will be, at the end of this session, students will be able to understand some important terms involved in electrochemistry and Nernst equation. So, things that are covered in this lecture are introduction to electrochemistry, some important terminologies in electrochemistry, and finally we will see Nernst equation. So what is electrochemistry? So basically electrochemistry is the study of relationship between the conversion of electrical energy and chemical changes. Reactions in electrochemistry, that is electrochemical reactions, involve movement of electrons from one electrode to other. This movement of electrons is responsible for electricity flow. The transfer of electrons from one electrode to other is known as oxidation reduction or redox reaction. Let's see one example of redox reaction. H2 plus F2 gives 2HF. In this reaction, hydrogen undergoes oxidation and produces 2H plus ions, and it releases 2 electrons. Fluorine, on the other hand, accepts those 2 electrons and it gets converted into fluoride ion. The overall reaction can be represented as H2 plus F2 gives 2H plus 2F minus. Let's see some important terminologies in the electrochemistry. First, electrochemical cell. It is the device that can generate electrical energy from chemical reactions, or it can use the electrical energy to start some chemical reaction occurring in it. So there are two types of electrochemical cell. First, electrolytic cell, and second one, galvanic or voltaic. In electrolytic cell, external energy or external power supply is connected to cell, and this is responsible for non-spontaneous reaction to occur. In galvanic cell, which is a spontaneous electrochemical reaction where from some chemical reaction electrical energy is being produced. So some important terms involves, first one need to know what do we mean by cathode and anode. So let's see first cathode. So it is a electrode where reduction reaction occurs and it is the source of electron. It releases electrons into the electrolytic solution and thereby it acquires positive charge. And in case of electrolytic cell, cathode is that electrode which is connected to negative terminal of the battery. Cathode is that electrode which is connected to negative terminal of the battery. On the other hand, anode is the place where oxidation reaction occurs and it is the sink for electrons. It accepts electron from solution. Therefore, it acquires negative charge on it. In case of electrolytic cell, anode is that electrode which is connected to positive terminal of the battery. Let's see some more important terms. Reference electrode. So it is that particular electrode whose electrode potential is known to us and which does not changes during electrochemical reactions. Examples include standard hydrogen electrode, silver chloride electrode, etc. Indicator electrode. It is that electrode whose electrode potential is to be determined during some experiment. It is that electrode whose electrode potential is to be determined during some experiment. Single electrode or half cell potential. It is the measure of voltage or electrical potential difference between indicator electrode and reference electrode. According to scientific convention, single electrode potential signifies potential of an electrode to undergo reduction reaction. Positive values of single electrode potential represents that electrode will undergo reduction reaction readily, that is, it can gain electrons. On the other hand, negative values of single electrode potential represents that electrode will really readily undergo oxidation reaction, that is, it will lose electrons. Nernst equation. So it is the very important equation from electrochemistry. So it is relationship between standard electrode potential, temperature, and the concentration of reactants and products in an electrochemical cell. Mathematically, it is represented as E naught is equal to 2.303 RT divided by NF into log of K, where E naught is the standard electrode potential of the cell, R is the real gas constant and its value is 8.314 kilojoule per mole, T is the temperature in Kelvin, N is the number of electrons transferred during some electrochemical reaction, F is the Faraday constant and its value is 96,500 coulombs, and K is the equilibrium constant of the reaction. So Nernst equation is E naught cell is equal to 2.303 RT divided by NF into log of K. By putting all the values of R, T and F, it can be further simplified as E naught cell is equal to 2.303 multiplied by 8.314 into 298 Kelvin temperature divided by N into 96,500 volt multiplied by log K, which on further simplification gives E naught is equal to 0.0591 divided by N into log of K. Let's see some numerical based on Nernst equation. The numerical is calculate equilibrium constant K for the following reaction. Fe solid plus cadmium 2 plus gives Fe2 plus cadmium. For this reaction, E naught for cadmium 2 plus to cadmium is minus 0.40 volt and E naught for Fe2 plus to Fe is equal to minus 0.44 volts. Let's see the solution. First, we need to calculate E naught cell for this reaction, and that is given by the formula E naught cell is equal to E naught cathode minus E naught anode, that is minus 0.40 minus 0.44, that will give the E naught cell is equal to 0.04 volt. In next step, we will use the Nernst equation. E naught cell is equal to 0.0591 divided by N into log of K, which on rearrangement gives log K is equal to N into E naught cell divided by 0.0591. On putting the values for this reaction, N is equal to 2, therefore 2 into 0.04 divided by 0.0591, which will give the value of log of K is equal to 1.3536. And the last step is the calculation of equilibrium constant, that is K, which can be calculated by the formula K is equal to 10 raised to log of K, that is equal to 10 raised to 1.3536, and which finally gives the value of equilibrium constant K as K is equal to 22.57 for this reaction. For this topic, we have used the reference, that is a textbook for engineering chemistry by Jain and Jain. Thank you.